On that last video there, now that we've talked about those alkyl groups, I would just like to look at now why that becomes so important is quite simply that we look at structural isomers, you see. That's why it's so important you're careful when you're naming. It is possible for a compound to have, or for a compound obviously it will have the same molecular formula which indicates the number of each atom in the molecule, but a different structural formula. Now that just is quite simply a fancy way of saying it has a different layout of the atoms. So here's the nice example. It's the same one as earlier, 2-methyl propane. See, both of those are C, if you count them 1, 2, 3, 4, you see C4, and count up all the hydrogens. You can count it in both of them and you will have 10 hydrogens in both of them. You see, look at even their chemical properties. Melting point and boiling point are not identical. You see, so shape does have the layout of atoms does have a difference in the chemical and physical properties. So this shape, there's a straight line and there's a branched shape, which is why we need to be quite clear. So there's the structural isomers, butane. Now sometimes it's written like this, which is somewhat expanded. Sometimes it's C. As you know, that we could write it as C4H10 would be one way of doing it, and they're all C4H10s. That's condensed. There's it sort of expanded to indicate the shape, where you have butane, and then the alternative would be 2-methyl propane. You see that methyl group is not on the end; it's up as a branch. And then there's it more expanded, if you like, with every single bond, every hydrogen. So these are, if you like, these ones on the left here are exactly the same. Like that's the same as that. It's just this is more expanded, and you can see each of the bonds, and likewise for the one below it. That's the kind of level that we look at it for leaving cert. You know, these will be the structural isomers. Again, that's the same one again. 3 factors: the number of carbons in the atom of the longest chain is how you name the parent molecule, I like to call it, and then the groups attached to that longest chain. Now normally for leaving cert that'll be an alkyl group most of the time, and the position then where those groups are attached is what's important. So there's pentane. You see, it is possible to have a branch. Look at, if you count the number of carbons there, 1, 2, 3, 4. Look at, there's 5 carbons. So you have the same molecular formula, but you don't have the same number or the same shape as, if you like, pentane. So again, you go through the naming system for this. Call this 1, 2, 3, 4. There's a long chain. You could try 1, 2, 3, 4. Again, you get the same kind of thing. You can start here, 1, 2, 3, 4. Now I won't pick that one. You see that one that I just did there. The reason I will is, look at that, leaves this one, which if you call this the branch or this the branch, when I say this the branch or this branch, I should really say use the laser. So when I said, you know, if you call this the branch or this the branch, it's still off carbon 2. Look at, irrespective you count that straight chain or this on, if you like, as it's written on the page, remember, because that's just on the page, it's not straight. Whereas if you look here carefully, what we'd actually be going for is to try and keep that number as low as possible. So 2 is as low as possible. We start here, it'd be 1, 2, 3. You see, it wouldn't be as low as 2. So that's where you do that. Now normally, just out of ease, I would always kind of use the straight chain, but you do not have to, because a lot of the time the longest chain is not the straight chain. Longest continuous chain of unbroken carbon. So here you have 1, 2, 3, 4. So again, off carbon 2 there, you have a methyl group. So it's 2-methyl. So that to name this, if you like, I'll just get my pen again. So it'll be 2-methyl, because methyl is, this is the methyl group, CH3, you know, it's methane without one hydrogen. You look up these, of course, when you have them in front of you, when you're looking at these. It's hard to write on this thing, but 2-methyl, and then the parent chain is 1, 2, 3, 4, and you look that up and you find that is But for 4, and ANE because it is an alkane, and that all the carbons in this backbone, this 1, 2, 3, 4 backbone, have single bonds, you see. 2-methyl butane. Look at 2,2-dimethyl propane. How did they come up with that? 1, 2, 3. You see, there's a long chain. Or you could go 1, 2, 3. And if you go this 1, 2, 3 right here, there's a methyl group and there's a methyl group. Because there's 2 methyl groups, you say dimethyl. Di as in for 2. Mono, di, tri. Dimethyl, and there's the methyl group. Because that's CH3 up here and that's CH3 down here. And then the longest chain, or the parent chain, is of course propane. If you count 3 carbons, propane. You get used to these names after a while, it becomes second nature. And then the other thing you just need to be careful about here is the fact that you have the carbons are off both the methyl groups. They don't necessarily have to be off the same carbon, but here they are. So you must put both of them in. So it's 2, 2. Now you can't see that right on the page there, but you can see it over here when we look at the actual name that I've typed up earlier. There you see it. You see it's 2, 2 dimethyl. It's 2, 2 because you have to, because it's dimethyl, di 2. So now that 2 and that 2 just stands for both methyls being off the same carbon. Because it is possible that they'd be off a different carbon. We just need to be conscious of that. Sometimes, you know, let's see if we can get one here that has it off. Again, that's 2, 2 dimethyl because it's off they're off the second one there. So you see here 2, 3 dimethyl propane. Why is it 2, 3? There's a CH3 off the second carbon and there's a CH3 off the third carbon, sorry. So the 2 and the 3 stand for the second and the third carbon. The dimethyl part stands for that methyl and that methyl, and the butane part stands for that longest chain right there. And the last, I think that's sufficient. So if we looked at those, if you look at this and the video immediately previous to this, that should cover the idea of structural isomers and having the same molecular formula but different structural formula, whereas it is possible for them to have that, if you like, the same molecular formula. Just don't get molecular mixed up with chemical. Chemical is too general. Molecular formula indicates the number of each of the atoms in the molecule, if you like. The structural formula gives you the layout. So, you know, each molecule will only have one structural formula, one molecular formula. Sorry, it could, for a molecular formula, like you could have 2 different shapes, just like Lego if you rearrange the pieces. As long as it still adheres to the same rules, every carbon has only 4 bonds, and every hydrogen has only 1 bond, and oxygen 2 bonds, and whatever else is added onto it. All right.